Dear students, today I am going to continue the problems for applying the Laplace for the product of exponential and trigonometric function. We call it as the shifting property. In my previous class I had given the formula for this, that is Laplace transform of exponential term when f of t is replaced by any other function. When f of t is multiplied by exponential function, that is e to the power at or e to the power minus at, then the formula already we have derived. In the previous section, that is e to the power at, the top one, this formula e to the power at, on the right side, this f of s is due to Laplace transform of f t, and this f of s, when s is replaced by s minus a, that is because of e to the power at is multiplied, that is a is with plus sign. Fine. What exactly the application for the problems we are looking for in this case is, when single function is there, we take Laplace transform with the definition directly, that is L of f t is equal to f of s, and Laplace transform of that particular function is multiplied by exponential term e to the power at, that is equal to f of s minus a. Let us continue this application of this formula to another 2-3 different types of cases, that is e to the power minus t and cos square t. Here in this case, cos is we are expecting with the first degree, because direct Laplace transform of the particular term, that is cos trigonometric function, we have studied as with the degree as 1, but here the degree is 2 and we have to convert this degree in the form of first degree, and then exponential term is multiplied. Afterwards Laplace transform is applied to product of these two terms, will have to be expressed in terms of f of s plus 1. That goes like this: L of e to the power minus t, it is cos square 3t. This we are expecting with the first degree, so that cos square 3t should be made as cos to the power of first. Then we have the formula, that is cos 2a is equal to 2 cos square a minus 1. So cos square is there, that if you separate from this one, cos square a is equal to 1 plus cos 2a and divided by 2. In this case, that is here 3t is there, so that in place of a, that is cos square a, that means 3t. You have to replace this capital A by 3t. As a result, that is cos square 3t is equal to 1 plus cos of 2 into 3t and whole divided by 2. This becomes, that is 1 plus cos of 6t and divided by 2. So this value I am going to replace in the place of that cos square 3t. Therefore, L of e to the power minus t, it is cos square 3t, can be taken as L of e to the power minus t into 1 plus cos of 6t divided by 2. Further, we can split this one, Laplace transform applied to the first term, Laplace transform applied to the second term. What is the property you are going to apply? In one of my previous lectures, I had told you that when you are applying Laplace to each term, that takes as the application of linearity property. Therefore, 1 by 2 Laplace transform of e to the power minus t applied to 1 and plus of, that is L of, that is also cos of 6t and multiplied to e to the power minus t and divided by 2. Now, in this case, from both the terms you can take 1 by 2 outside, then L of e to the power minus t and plus of L of e to the power minus t cos of 6t. This happens to be, that is f of t. Firstly, you have to write what is the Laplace transform of this function and express it by the definition of Laplace transform as f of s, so that becomes f of t cos of 6t. Then applying Laplace on both sides, L of ft is equal to L of cos of 60 is equal to S divided by, that is S square plus 6 square, that becomes S divided by S square plus 36. This is the value, and we name this value as function of S, because our basic definition is L of ft is equal to 0 to infinity e to the power minus st, f of t dt is nothing but f of s. Here this f of s means definite integral t is equal to 0 and t is equal to infinity gives us the final result in absence of t, but in the presence of s, so that we call it as f of s. Likewise, s divided by s square plus 36, we can name it as f of s. Then using the shifting property application, that shifting property says like this: L of e to the power at f of t is equal to f of s minus a, and at the same time this is plus minus, but here minus plus, like that. Opposite sign we have to assign. In the property already we have defined, that is, if plus is there you have to put it as minus, if minus is there you have to put it as plus sign on the right side, because this comes by the application of basic definition of Laplace transform for the product of two terms inside. Then compared to that one, then first term is not the shifting property application, so that this is equal to 1 by 2 1 divided by L of e to the power minus t is nothing but s plus 1 and plus of, that is cos of 60, that is f of s, and should be written when exponential is multiplied, means the meaning is s is to be written in terms of, that is s minus a, because this f of s is due to single function, but this f of s minus a is due to product of two terms. So single term and two terms. So single term f of s and product of two terms, depending on the sign we have to write the result. So as a result, wherever s is there, this clearly explains the meaning. F of s minus a clearly conveys the meaning that wherever s is there, that s is to be replaced by s plus a. Therefore here e to the power minus t is there in the given problem, e to the power minus t is there, so we have to make it as plus sign, s plus 1 over s plus 1 whole square and plus 36. This is your answer. This is the first case. Another one in terms of trigonometric function, that is sine. Here e to the power 3t, in the similar way we write for this sine to the power 3, because degree sine to the power 3 it is given in this problem, it is a product of exponential, that is 3t, and sine cube t. So this also to be reduced to the first degree, where you have to use the formula, that is sine 3a is equal to 3 sine a minus 4 sine cube a. So if you use that formula, let me give the small hint for this one. L of, that is e to the power 3t and sine cube 2t. In this problem, this is also because Laplace transform of cos to the power first degree we have, and similarly Laplace transform of sine to the power first degree we have the formula, but here the degree is 3, it is more than 1. Therefore you have to reduce it to 1 and then you have to apply the Laplace transform. What is the sine cube 2t in terms of first degree, we can explain. We have, what is that basic formula you have studied even right from 12th standard, you have studied the trigonometric functions and the relations between trigonometric functions. That relation goes like this: sine 3a is equal to 3 sine a minus 4 sine cube a. We want sine cube a is to be separated, so that you can interchange this one. Sine cube a is equal to 3 by 4, because 4 comes to the denominator, and sine a 3 by 4, because when you take the whole product to the left side and this is to be shifted to the right side, and you can write only sine cube a in the left side and sine 3a on the right side. Therefore 4 should be divided for both the terms on the right side. Therefore 3 by 4 sine a minus here 1 by, that is sine 3a, when you write here 1 by 4 only, but here 3 is there, 3 by 4, here 1 is there, 1 by 4, and then sine of 3a. You can easily make out sine cube in the left side, sine to the power degree 1 and sine to the power degree 1, but the angle is a in the first term and the angle is 3a in the second term. No, that is no problem. Then we can replace this function L of e to the power 3t, then this can be written 3 by 4 inside the bracket, sine of a is equal to 2t in this case, minus 1 by 4, and sine of a, that is equal to 2t, but here it is already 3 is there, therefore 2 into 3 means 6t. This is the converted formula, otherwise converted function. Then what you can write, we have to write Laplace transform using the shifting property. Therefore shifting property means even further one step you can write like this for more clarity. That means constant you are taking outside, here 3 by 4 I am writing, and L of e to the power 3t and sine 2t, one product, and minus 1 by 4 L of e to the power 3t and multiplied by sine of 60. Now you have to study Laplace transform of both the products, one is 2t, another one is 6t. In this case this can be defined as f of t and this can be defined as f of t. The formula says here L of e to the power at plus minus at, accordingly on the right side that is s minus a and s plus a. Okay. In both the cases that a is positive, then you have to write negative on the right side. So 3 by 4 and its fs, ft is equal to sine 2t. Already we have derived elementary Laplace transform for sine trigonometric function. L of sine kt, otherwise sine at, is equal to a divided by s square plus a square. In place of a, in the first Laplace transform it is 2t, in the second Laplace transform it is 6t. Therefore we have to write, that is 2 divided by, wherever s is there you have to replace that by s minus a form, therefore s minus 3 whole square plus, that is a square, that means 2 square. This is one term, minus 1 by 4, and here same a value where exponential has taken the degree as 3, but another term is sine of 60. Sine of 60, there it is comparing with, you can easily make out with the formula, that is L of sine at is equal to a divided by a square plus a square, but in the second term, first term a is equal to 2, but second term a is equal to 6. Therefore denominator accordingly you are getting the square of it. What is that square? Here on the right side, that is 1 by 4 into 6 divided by s square, means s minus 3 whole square and plus 6 square. You can directly write that is equal to 36. So that is the result. And one more step, if you want for a more simplified step, that you can write it as 2 square. Even you can take the LCM also between these two, and this part will come to the numerator and this part will go to the denominator, numerator on the second term, but numerator completely you can expand it and then simplify, some more simplification. So that gives, this is the term like 48 divided by s square minus 6s plus 13, and one more product is s square minus 6s plus 45. So this is the term we are getting. Now let me continue for applying another property. So like this you can study different trigonometric functions. Two cases I have shown, one is cos trigonometric function and another one is sine trigonometric function. But in the previous class, previous discussion we have taken, that is exponential term multiplied to f of t is equal to some other term like even variable also. So that variable type, some special type, now I am going to discuss. What is that other than exponential, what we are going to do? That means here you can see that L of t cube into e to the power minus 3t. this is somewhat like typical problem, and you have to understand so much of information in this problem. What exactly that typical problem criteria included in this problem is, you have t cube is multiplied to exponential term, that is e to the power 3t. Yes, when if you interchange these two terms, like t cube if you write in the second position and e to the power minus 3t if you write in the first position, what happens? Now we have completed this exponential term is written in the first term and another term is written on the right second position, then it is nothing but shifting property. But here it is t cube is written in the first position and exponential term is written on the second position. If you interchange this, then this problem can also be converted in the form of shifting property application. But sorry, but in this problem t cube means algebraic term. Algebraic term appeared in the first position and exponential term appeared in the second position. Let us give the solution as it is. Whatever this problem statement is there, as it is, let us give the solution, and also I will interchange this product and then I can give you the hints how to apply the shifting property. So in both the ways you can solve this problem when exponential and algebraic terms are multiplied, but not for other cases. These two things can be interchanged. Now let me solve this one using another property, that is derivative property we can call it. Otherwise some authors also they name it as multiplicative property. That means the function in the Laplace transform definition is multiplied by algebraic term. Algebraic term is, that is a general degree t to the power n, but here in this problem statement it is given as, that is degree n equal to 3. Let us find out how this solution goes, because we start with the t to the power 1, t to the power 2, t to the power 3 and like that. Here t to the power 3 means, according to derivative property, you are supposed to differentiate 3 times by writing the f of s, whatever the function you are going to define it as f of t, which will be converted further as f of s. This is a very typical problem. L of t cube and e to the power minus 3t. Let me solve this by two ways. First method, that means first method I can call, otherwise first procedure. First method as it is. Therefore L of t cube into e to the power minus 3t is equal to L of t to the power n and f of t. This is your formula. I mean comparison. Algebraic term multiplied to the original function. Original function here it is given as exponential. What is our standard formula says? In one of the previous classes we have derived that derivative property. What is the meaning of that derivative property? Means here this is derivative property when t to the power n is there, that derivative property takes on the right side minus 1 to the power n dn divided by dsn of f of s. Dear students, you have to understand too many things when you are writing this expression, because this is your problem statement, this is your formula LHS and this is your formula derived and the result is on the RHS. You can easily compare the product as it is, that is t to the power n, so that this is f of t, so that this is f of s. That means you have to write the function of s from the given term, that is function of t. That is function of t means e to the power minus 3t should be written first of all, compared first of all with respect to t, that is function of t, and then you have to write f of s, and then you have to identify from this formula and the given statement, that is t to the power, otherwise here itself. That means n equal to 3. You can easily make out. Yes, what the secrecy of mathematics and the problem's solution, you have to be very sharp enough in understanding the problem and then rewriting the problem according to the standard type. Normally it goes for most of the cases in the mathematics, it is like this. When you write the basic first step, that means first few steps properly, that means when you understood the problem, that clearly indicates you know the solution. If you do not understand the problem, I am sure that blindly you will write something and then end up with some wrong results. So that should not happen. Take maximum care when once the problem statement is given, that problem statement must be properly compared with the formula. Here n equal to 3, f t is equal to this one and its fs is to be written. Okay, let me take f of t is equal to e to the power minus 3t, implies how you are getting fs? Fs you are getting by applying the Laplace transform basic definition. Yes, what is that basic definition? L of f t is equal to L of e to the power minus 3t, that is 1 divided by s plus 3. As I already told you, minus is there, you have to write it as plus sign, means opposite sign you have to write, and this is to be named as f of s. Then application of this formula, that is 1 by s plus 3 will be directly treated as f of s, and I am going to use this formula by putting this n equal to 3. Therefore, that is equal to minus 1 to the power 3 and then d cube divided by ds cube of 1 by s plus 3. This is almost more than 50%, in my opinion, more than 50% of the solution is completed. Rest of the details what you are going to present are nothing but differentiating that 1 by something for 3 times, because 3 times you have to differentiate, this differentiation symbol can be eliminated. Okay. So, minus 1 whole cube means minus 1, because minus 3 times, and d square by ds square applying, that is d by ds of 1 by s plus 3, like this. Otherwise, minus 1 d square divided by ds square, d square by ds square. Once you have to differentiate, differentiation goes either by u by v formula, or another shortcut method is like this. This you have to take d by ds s plus 3 whole to the power minus 1. Directly you can write the result, because in the numerator no variable s you have, so that without any hesitation you can write in the numerator. Minus 1, it is d square divided by ds square, s plus 3 differentiation is minus 1 into s plus 3 whole to the power minus 1, that is minus 2. Then further this can be written as, that is equal to minus 1 d by ds, again d by ds of minus s plus 3 whole to the power minus 2. Here already from d cube by ds cube we reduced it to d square by ds square after differentiating once. Now another time when you are differentiating, and outside it is with first order derivative, minus 1, then d by, it is ds, that should be minus s plus 3 whole to the power minus 3, and this becomes minus 2 and minus sign, this is plus 2, should be multiplied. And finally, one more time you have to differentiate this function as it is, minus 1 and plus 2 into s plus 3 whole to the power minus 3. That becomes plus 2 into minus 3, because you know the differentiation formula, x to the power n is equal to n into x to the power n minus 1. Therefore, this plus 2 and minus 3 is to be multiplied, otherwise you can put it in the brackets in 2 different positions, and then s plus 3 whole to the power minus 4. So finally, there are 2 times minus sign appeared and 3 2s are 6. Therefore, s plus 3 whole to the power minus 4, and finally the answer is s plus 3 whole to the power, that is 4. This is by direct procedure, that means direct method we are applying, and direct procedure 6 divided by s plus 3 whole to the power of 4 we are getting. Now, if you use this term in the first position, that means exponential term in the first position, and algebraic term in the second position, you can also apply directly the shifting property concept, because in the previous problem already we have studied about that one. I call it as a second method for the same problem, that is interchanging that one. If you know that, you can apply this concept, otherwise you can skip it and then you can go for directly as it is the statement is given, algebraic term first position and exponential term as the second position. Fine, let me give an alternate method for solving this one, that is I am taking like this, let L of t cube and e to the power minus 3t, it goes like this, L of e to the power minus 3t and then t cube. Now you have more advantage when you have the products of this kind, because easily without doing all these number of steps, within 2 steps you can write the answer. This may be the another method, we call it as a shortcut method, like what technical aptitude test questions you are getting for company selections. Normally it happens in 6th semester. Such are the questions, they will expect more number of questions to be answered in less number of time. Therefore, these type of methods immediately you can think of and then apply. Application goes like that. So that how it goes here, and this will be compared with the shifting property L of e to the power minus at and then ft. In the previous problem we discussed. Okay. So here ft becomes t cube and its fs. So directly I am writing its fs. Then f of s for this term t cube, L of t cube is equal to n, t to the power n is equal to n factorial over s to the power n plus 1. So that is your result, that is f of s. By the definition of Laplace transform, directly you are writing f of s. Fine, here in the case of t cube, then your fs becomes, that is 3 factorial, means n factorial according to formula. What is that formula? L of t to the power n is equal to n factorial over s to the power n plus 1. I make use of this result when I am extending Laplace transform for algebraic term. Therefore, 3 factorial divided by s to the power 3 plus 1, it is 4. Then you will call it as this one as fs. So because of this multiplication of exponential term, you can simply extend your concept or extend your idea that shifting property application will be hold good. 100% that shifting property must be hold good. How it is? Wherever s is there, you have to replace s by s plus a. Here a is equal to 3. Therefore, that is 3 factorial and divided by s plus 3 whole to the power of, that is 4. This is your answer. If you want to conclude directly, that is 3 factorial is 6 and then s plus 3 whole to the power of 4. So this is the procedure. So only I call it as a typical problem. You can interchange, or you can solve directly, or you can interchange the things like this. Next problem, that is L of t to the t into sine square t. Here also sine square t happens to be the comparison with the formula, that is differentiation one time which you have to do. Let me explain. Here also it is the constant term, only one step or 2 steps. I hope you can easily make out what we are going to do here. Then L of t into sine square t. Now same type you compare L of t to the power n f of t. Here f of t is sine square t, but we do not have the formula. Just in the previous 1 or 2 problems we have explained about how to reduce this second degree into the first degree. Therefore, and this is equal to minus 1 whole to the power n dn divided by ds to the power n of f of s. F of s. Then what is this f of t here? That is f of t and then it is f of s. So f of t is equal to sine square t. Already you are familiar with cos 2a is equal to 1 minus 2 sine square a. Therefore 1 minus cos 2a and divided by 2. Cos 2a instead you can write directly as cos 2t. Therefore this problem will be converted L of t into sine square t is equal to, should be L of t multiplied as it is. In place of sine square, you are putting it as, because sine square is reduced to the cos to the power first degree. Therefore, 1 minus cos 2t and divided by 2. So that you can split the problem into two terms. L of, that is t is the first term, no property you have to apply, directly elementary Laplace transform you can apply. This is one term, minus 1 by 2 L of t into cos of 2t. Now you have to study about these two cases. These two cases individually, Laplace transform for algebraic term and Laplace transform for the product of algebraic term and trigonometric function. This can be directly written 1 by 2 L of t is 1 by s square minus 1 by 2. From the elementary Laplace transform already we have derived, and I am making use of that result to write L of t to the power n, that is n equal to 1. So that 1 factorial divided by s to the power 1 plus 1. Therefore, minus 1 by 2 and then L of t into cos 2t. L of t into cos 2t means this formula takes, and here this gives us n is equal to 1. Therefore, minus 1 to the power 1 and d by ds, then cos 2t. Directly f of s for cos 2t, that is Laplace transform of cos 2t, will be reduced to f of s. It goes like this, s divided by s square plus 4. Now you have to differentiate this one by u by v formula. Therefore, 1 by 2 1 by s square minus plus, it is this one, and 1 by 2. Once you have to differentiate, that is all, because n equal to 1. What is that u by v formula? S square plus 4 into denominator into derivative of numerator is 1 minus numerator, that is s, into derivative of denominator is 2s, whole divided by, it is s square plus 4 whole square. Rest is to be only the simplification. We can continue that one. So, when algebraic term is multiplied to exponential, when algebraic term is multiplied to trigonometric function, and exponential term is multiplied to trigonometric, and exponential term is multiplied to algebraic term. Like this we study among three important properties of Laplace transform. These two are the properties. So, we shall take another most typical problem. That means, I started with elementary, then I took the typical problem. Now I call this one, I call it as most typical problem, because this is some unique nature of the product, nature of the type of product it is appeared in the problem. This is t into e to the power minus t, that is sine 2t. This problem also, this is a mixture of exponential property, derivative property along with trigonometric function. This problem also you can handle or you can solve by going for two different options. One is keeping this product as it is, and you have to distinguish clearly algebraic term is multiplied, this is t, algebraic term is t is multiplied to e to the power minus t and sine 2t. This e to the power minus t into sine 2t, you can treat together this product as f of t and then find its fs. Afterwards, derivative property can be applied. This is one option. Second option, if you keep this exponential term outside and t, if you t and exponential if you interchange, that leads to the application of shifting property, because t into sine 2t you can write using the derivative property and write the answer, and whatever that answer comes by the derivative property, you can simply name it as f of s, and that f of s once again will be applied in terms of exponential term multiplication as shifting property. Otherwise, then as it is means first shifting property you have to apply and then derivative property you have to apply. So, one sample let me show, because this is in most of the examiners prefer to take this type of problems or check this type of problems with the knowledge of all our students. Yes, how to proceed to this problem, and then how to write function, select the function and how to write f of s, and then how to apply the formula at the end. So, two options I am giving, t into e to the power minus t, that is sine of it is 2t, like this. So, this will give two options. One is L of as it is t into e to the power minus t into sine 2t, and this can be compared with, that is L of t to the power n and f of t, and this will be minus 1 to the power n and dn divided by dsn of fs. Then how we are going to compare? The total bracketed quantity will be taken as ft, and this has to be written as fs, and this n will be equal to 1 according to this option which you are going to select as it is, the product whatever is appeared in the problem statement as it is. Another option, that is L of e to the power minus t into t, if you interchange these two, and then sine of 2t, this is going to be shifting property application, e to the power minus at, and then f of t, then f of s plus a. How it goes? This becomes ft and this becomes f of s plus a. That is, this is called shifting property, this is called derivative property. You can take any one of these options. Normally this type of questions you will find in the examination more normally. So you can go for any one of these two options, whichever you feel convenient, but in my opinion both you have to practice, because these things will go as applications in the engineering problems. Whenever the flow of the current in the circuit, especially in electrical engineering and electronics engineering, Laplace transform they are going to use to solve the initial value problems. When they come across product of two terms, product of three terms, like that, the flow of the current through the circuit, we call it as LCR circuit, that is capacitance, inductance and resistance circuit, that too with capacitor and without capacitor. So we will be discussing at the end of this topic, this module, as applications of this Laplace transform will go for solution of differential equations. But well in advance, if I want to say something about this one, you will after applying the Laplace transform and then using the initial conditions, you will come up to certain stage where you have to deal with Laplace transform of product of terms. Then in such cases, what type of product you come across? If you come across product of only two terms, then any one of these three properties will be taken for the further processing. But if you come across product of three terms, then you can use and save the time if you go in which way, if you proceed in which way, so that you can get the answer within lesser time. So that this problem is such good example, one such good example which you can solve. Let me solve this problem as it is in the first step. So second one easily you can make out. If I take this f of t, then e to the power minus t into sine of 2t. What is this? Directly I can write without any hesitation, because so many terms already we have discussed on this application. So sine 2t, in this again f of t is that, sine 2t means that is 2 divided by s square plus 4, but here 2 divided by s plus 1 whole square plus 4. This is to be taken as fs. That is what I want to convey here. Ft, its totally product, and it is written as fs. Now I call this one as fs. Now I treat this property, this statement according to the property, algebraic term is multiplied. Find L of t into e to the power minus t into sine 2t. It's okay. Then I have to write, because of this the algebraic term is multiplied, I have to go for derivative property. Therefore minus 1 to the power n, here n is equal to 1, and only once you are supposed to differentiate. And what type of differentiation term? That is 2 divided by s plus 1 whole square plus 4. Then if you do perform this differentiation, that is sufficient. What is that? Minus 1, and then this is u by v formula, that is s plus 1 whole square plus 4 multiplied by 0. That means u by v formula, you are applying the concept denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator whole square. Accordingly I am going to write minus of 2 into, this is 2 times s plus 1 divided by, and this term becomes 0, and s plus 1 whole square and plus 4. Then that is first term completely becomes 0, and bringing this minus sign, this minus makes us minus 4 into 2 into 2 4 s plus 1 over s plus 1 whole square and plus of 4. This is your answer, and same answer you must get in another method also. Therefore, any one method which you feel convenient, you must be ready for applying this type of concept. Like this you can extend many of cases as Laplace transform. So, the next problem we will take another important property, last property application in this particular chapter title, that is integral property. Integral property, some authors they write, and some authors they call it as when t is written in denominator, it is division property, because earlier one is multiplicative property and this one is division property, otherwise integral property. What is that integral property concept? We studied elementary Laplace transforms for single terms inside the Laplace transform operator, and here this type of problem we are going to study when that function inside the Laplace transform is divided by the algebraic term. What is that formula and where exactly we are applying, especially in the case of engineering problems, like then once again it will be used in instrumentation, that is instrumentation and engineering. Even in biomedical engineering, differential equations we come across. In those biomedical engineering problems, we have to solve the differential equations with initial conditions. There also we apply all these three important three properties of Laplace transform. Now, what is that property we studied here? L of ft, that is divided by t, is equal to s to infinity, that is f of s and then ds. This f of s once again is due to application of Laplace transform to get this value as f of s. Therefore, L of f of t by t is equal to s to infinity f of s ds. So, based on this formula, we have the statement, that means problem statement is like this: cos a t minus of cos b t divided by t. We have to find out, that is cos a t minus of cos b t divided by t. One has to understand, when t comes in the denominator, it is a division property. One has to understand, when t comes as coefficient to the function, you have to immediately go for application of derivative property. And when exponential term appears in the first position, and also the second function, second location as the function, maybe trigonometric, maybe algebraic, maybe some other type with variable, then you have to apply that one as shifting property. These three important properties will play the role. Okay. When I compare this one, here two integrals you have to write. One is L of cos a t and divided by t minus L of cos b t and divided by t. If you compare with this, in both the cases f of t happens to be the numerator. F of t in the numerator of the first Laplace transform is cos a t, and f of t in the second Laplace transform is cos b t. Okay. Already you can easily make out from numerator f t, you want to place that value as f s, means in between these two Laplace transform operator will be applied, because from f t you have to get it as f of s, and it is to be integrated between s to infinity. Then directly if I want to write, I hope you are much familiar already by writing cos of a t in terms of s, that is function of s, and what is that value of cos a t? Cos a t value in terms of f of s is equal to integration, that is s to infinity. The value of f of s is s divided by s square plus a square, and it is with respect to s, minus same thing s to infinity, and here cos b t, that is s divided by s square plus a square and then ds. Now you have to perform these two integrals between the limits s to infinity. Now, what is the integration of the first term? This one, you know the formula. Once again, your basic formula, that must be f dash x divided by f x and dx. Even in PUC syllabus, that means even from CBSE scheme, means 10th standard itself, these formulas are already defined. integration and differentiation. Now, what is the basic integration we are going to apply? Here exactly this must match, the formula should match with this existing term. What is that? If the derivative of denominator appears in the numerator and the ratio of that under the integral sign will be written as log of the denominator. This is log of denominator and plus constant maybe, but here it is a definite integral, constant will not be there. Therefore, this how we are going to write. So, this f x gives f dash x, otherwise f dash x is the derivative of f x. Now, this derivative of the denominator, that is s square plus a square, gives the derivative as that is 2s. 2 is not there, then you have to divide. Therefore, 1 by 2 log of, it is s square plus a square, and then in fact both are with respect to s to infinity, lower limit and upper limit, and the second one, that is 1 by 2 log of, it is s square plus a square, and both are to be defined between s to infinity. Now, both you have to discuss, you cannot leave the answer up to this stage itself, and you have to apply the limits between s to infinity. Here s to infinity means log infinity, here also log infinity, that is a maximum value. In both the cases, if you leave this answer with the application of upper limit, means infinity minus infinity, that cannot be accepted because it is indeterminate form, meaningless quantity in the mathematics. So, to avoid that meaningless quantity in the mathematics, what we do, that is we take s square outside, here also s square outside, we expect this s square or s should come in the denominator, so that we can avoid this infinity by rating its calculated value as 0. Therefore, there if you work out, only the lower limit term will have to be placed as replacing s by s, and here also s by s, and then we can do some simplification. Up to here, let me give a break, and then if there are any questions, you are free to ask.